Hey, this is Rob, and I went down the rabbit hole. Again. And I mean way down the rabbit hole. I'm trying to make wavy staves. So the first question is, what is a stave? You already know what wavy means. A stave is a slat of wood that wraps around a cylinder. So think like a wine or whiskey barrel, those slats that go up and down around that barrel, or in my case, a drum. But wood turners and people make these shapes all the time. It's not just for drums or whiskey barrels. I'm not saying I'm the only person to ever do this, but I'm also saying I've never seen anyone else do this before. So someone might be doing this, but if they are, they're not showing pictures of it online or doing videos like this, of course. For this video, I'm going to take a shape in my CAD program, which is vcarve Pro. I'm going to make a single toolpath that outlines that, and then I'm going to take that toolpath, import it into a spreadsheet, and do many toolpaths based on that, creating an angle on the outside edge. This sounds complex, and for my brain it is quite complex. I'm using trigonometry that I have not used since high school math. So in my brain this is 40 years old, and of course I did have to Google these formulas. I did not remember them. But I think I have a process that actually works now. And this spreadsheet I'm going to share at the end of the program. So if you want to learn to do this, if you're a drum builder or a wood turner and you want a cylinder like this, watch the video, and at the end you'll see how to get this spreadsheet I'm working with. Also in this video, I'm going to talk a lot about G-code and take an in-depth look at that. Some people think that sounds wonderful. And if you do, you're a geek like me, because most people are going to find this boring. I already know in my YouTube statistics that the average viewership on this video is going to be like 30 seconds, and people are going to click off because that does not sound exciting to them. That's fine with me. You're not going to hurt my feelings if you've watched this and click out now. That's fine. This is for real CNC geeks. So let's get started. I already showed the basics of what a stave actually is. Here's a website that most drum builders use. It's from uniontownlabs.org. Give us some credit. Almost everyone uses this for making shells if you're a drummer. And we'll put in some parameters here. It's already basically set up to what I want. I want 20 staves as my test example. And it's a 14-inch shell, which they even calculate that it's 13.875 actually. The drum head is 14 inches, so if you make the drum 14 inches, the drum head won't fit over the drum. So even if it's a 14-inch drum, it's really 13.875, but no one says that. It's a 14-inch drum. And it talks about the extra diameter. That's that 1/8 inch. That's the difference right here instead of 14. And the height of the drum doesn't really matter for what I'm doing. So the important thing is you got individual shells or staves. You can see how it works here. They use 2.24, and there's a gap right here. You can see that gap. I usually go 2.22 just to get close to that outside edge, and I have a little more stave inside to work with if I want a thicker drum on the inside, or for some reason I want to do something inside the drum. It's an 18 degree angle, which is important. We'll use that later. And each side is 9 degrees. From dead center, it's 9 degrees. Of course, then you have the other one here. That's 9 degrees. So that joint is 18 degrees when you put both together. And of course, you have 18 divided by 20 staves. It comes out to 360. 360 divided by 20 is 18. So that's how you get those basic numbers. So let's go into my vcarve program. And here's kind of basically the same thing we just showed. This example stave is 1 inch tall, just for examples. And again, there's that 9 degree angle in. And notice if it's 1 inch tall at 9 degrees, we're going to have 0.1582 difference if it was going straight up versus that angle, if that makes some sense. My goal, what I want to do, is to cut down, so this example, 0.5 or 50 thousandths, but my spreadsheet will do whatever we want. So we'll cut it in a little bit, one more layer down, in a bit, and we end up with many cuts down here. In this example, it's 20 cuts to get that angle just right. So it's not going to be a diagonal bit doing this. It's very many straight edges cutting down to get the feel of that straight edge, or that angled edge. So the drill bit, let's show the drill bit. The router bit, so that's my rendering of what a router bit looks like. Notice this is the center point of the bit. That's the actual tool path that'll follow when the CNC machine works with. It thinks as far as the center, not the edge. So it makes adjustments to get the shape we actually want. So the first cut, the zero cut doesn't count because it's be at zero depth. Then we go at the depth right here. We'll do one pass, another pass at this depth right here, another pass here. We'll keep working our way down to get that angle to work out right. So let's look at the shape I want to do now. And this is an extreme shape. I do not want to make a drum out of this shape. So that's the shape I'm going to do. Very extreme. Maybe I will do a drum like that someday, but I don't see that what I want. I will probably do a gradual curve back and forth, not even that extreme, a very gradual wave. Think of waves like in the ocean or a ripple on a flag, things like that. How I do it, I still always use this top edge is 2.22. Let's do a quick measurement to show what I'm talking about. And that is, well, 2.21 it shows here when I do that. There's some rounding involved in there, but that's the basic size I want, that outside edge. And when I do these, that outside edge is still always going to be consistent. In theory, I could have it smaller here and then another wedge, a different shape. As long as they average out to 2.22, it'll still work. But for my example, it's always those edges are the same. Also notice I have a clamp there. So when I cut this, I have to attach this to the CNC somehow. So I'm going to have it when it cuts, it'll cut each side where he's over the clamp and start again the other side. So it'll be consistent like that. So these always join up perfectly lined. And in the real world, there has to be some tolerances there. And for this example, I did 0.005 or 5 thousandths gap between those. So it'll join together. And when I did my test, that's actually a little too much. In the future, I'll probably go 3,000 instead of 5,000, so everything joins together just right. So to get that, I took this piece, went to offset, inwards, 0.005, and usually I hit delete the original, but I'm not going to do it this time. So notice there's one inside there. We just created this one that's inside there, and that is this one right here. So if I drag this over, oops, this should be that exact shape. And you can see, yeah, they're on top of each other. So I'm going to hit delete button and get rid of that copy. Now the problem is, I mentioned how I'm going to pop over here. I'm going to do a separate toolpath for each side. So normally when you cut this out, you would tell it in the toolpaths, you would hit this and go, and you'd cut outside edge, the 1/4 inch bit I'm using in this example. I can't do this, so it would cut right through my clamp. And also, I might do different shapes on both sides, so I want to have a toolpath for each side. So again, I'm going to highlight this and do my offset. This time I'm going to go outside. And since the router bit is 0.25, I'm going to go outside to half the middle point of that router bit, which is what the CNC thinks in, is that it always, when it sends a toolpath, it's thinking the center of that bit. So I'm going to expand that out, 0.125, offset. There we go. And I'm going to go into edit node. So N. I'm going to delete this outside edge. And the same thing down here. Delete the outside edge. So that's the actual toolpath the bit is going to follow to find that. One other quick thing here. This is working with curves. You can see that's a curve. You can change that. I do not want curves. When I create my toolpath, it has to be point to point to point in a straight line. That's how my spreadsheet works. That's how all the trigonometry works. So I take this shape and I'm going to go into this button and I change it to straight lines and preview all those straight lines, hit OK, hit N for node edit again. So all these straight lines. So when we look at our G-code in a little bit, each one of these from this point to this point is a line of G-code, another line of G-code, another line of G-code, point to point to point. There are going to be thousands and thousands of points, which to my brain is very complex. But to the computer, it's nothing. It's just a bunch of points connected by XY and XY, these 2 points. The computer has no problem doing this. So we like having this horsepower that computers have nowadays to do calculations like this. So when we calculate a toolpath, which I've already done, but let's do it again just because. I'm going to take it back out of Node Edit, hit Node. I'll do both these together, though you don't have to. You can do one by each by itself. And I've done multiple examples or tests doing this, both combined and by themselves. Go to a profile, and I'm going to go on that edge with a 1/4 inch bit. Now, part of what I'm doing here is I want to do one pass. I don't want multiple passes. So I want one pass, so I'm only going 0.01 or 10,000ths of depth cut. When we finally get done to this, this will be the outside edge of the part we're talking about. And we'll start inside and keep working our way out till we get to that final shape. So I'll go ahead and calculate that. I won't even bother changing the name. Profile 2, go back to this. I like this option right here. You can press that button, it'll show what actually is cut out. Notice how it conforms exactly to that shape. That's why we created this piece 1/8 of an inch out, 0.125 out. So now it conforms exactly to the shape we cut using that bit. So we kind of tweaked the toolpaths how it works. I will create a toolpath for that and export it out. And in a second, we're going to go and look at that toolpath and import it into the spreadsheet we talked about. Here is the spreadsheet I've referenced multiple times now. For the general part of the spreadsheet, the only thing you'll ever touch are the highlighted yellowish, orange, whatever color it is, here and here. Nothing else you actually touch. Well, you'd click these buttons, they do things, but otherwise, everything else is formulas you don't touch. I touched on using trigonometry before. So if we have a right triangle, so we have from this point, this triangle, use that line, the center 0 line, out by 1.11 and back up, it will calculate the angle from that. That'll come out with that 8.97. But if we change that to a much smaller drum, say if the point was right here, say if it was this is a 14, so it's a 7-inch drum, half the point, this angle would of course be much more dramatic. So let's show how it works there. We got a 14-inch drum, I'll put in 7. And we'll watch this angle column. Yeah, it changed almost double. It probably is double exactly. So 17.52, take it back to 14. It's thinking. There we go, 897. That's not quite double. But still, that's how the trigonometry is calculating these numbers. That's why it doesn't quite match up to the 360 divided by 20 to get that number. But these calculations after calculations and calculations. So that's why that number matters. If I change the wood thickness to 0.75, first of all, we'll do 19 passes. We were calculating on a 1-inch drum before. Now we change it to 3/4, so it doesn't make much passes. And 0.75 does not divide evenly into that, so it's actually be 0.0395 instead of 0.40 even. The size of the end mill would change. I'm going to put a big number in here, like a 2-inch end mill. And suddenly, it takes a while to calculate. Well, our angle changed to 1.88. So in the formula, I take out, I should go to angle here. Size end mill is B2, and we're going to find, it's B5. And find B5 divided by 2, because the CNC uses the center point of the bit, not the width of the bit. So be 0.125. That's how I change that. I'll change it back to 0.25. And it'll change that angle dramatically again. So many calculations, so many trial and error for me to figure this stuff out. I do not claim to be a math expert, though in my brain I probably think I am, but I realize in the real world what I do does not really add up. So that's covered all these in this column here. I'm going to change this back to 0.04 just to make it easier to work with. From here down is the actual piece of G-code we created a second ago. I'm going to drag this onto the screen here. Here it is. To understand G-code, there's always a header and a setup then the actual tool pass, where the bit is actually moving along our item. That'll go on for a while. And I'm going to hit Control Shift down, which doesn't work in that application. So we'll drag to the bottom. After that movement, then there's the footer, they call that, which always happens at the end of every piece of G-code we create. So the header, footer, and setup are consistent. No matter what you're cutting out, those should be exactly the same. The actual tool path starts after that setup part. For mine, I put in a spot where I pause everything for 3 seconds while the spindle starts to speed up. You probably don't have that, so you need to figure out where your movement actually starts on this. On this one, it moves to the specific spot at 0.65 above. That's my section in vcarve, the setup, where we have the clearance set. And that's important because my clamp I have is about 0.55 thick, so I want to be a little above that so it doesn't cut my clamp in half when it goes between those two. So that's why I have those settings there, so it'll hop over that clamp later. So you need to figure out this on your own. I can't help with that because they're all different. But at this point, that's that, removes that beginning point, then it drops down, and here's the actual first line where it starts cutting. That's where the Z goes to minus to negative, below 0. So that's important. It goes all the way down here. Actually, let's go back up. I went too far. That's where it hops over the clamp. It raises up, goes over the clamp, and it comes down to here. In theory, it thinks it's done. It raises up to 0.65. We saw it number 4. And here's the footer. We don't worry about that. So I'm going to copy that bit of G-code. So I'm going to Control C, copy. And what I normally do is I'll paste it here. But first, we want to blank out what was there before. So I'm going to click Delete G-code. It's running a script in the background. One little side note, if you download this application, this spreadsheet, the first time you run that, it could give you a warning, say, hey, you're running some code that they might not trust. They don't know who I am. You don't know who I am. So it might give you a little message to say, do you trust this user? And potentially, a bad person could put code in here that could do bad things to your machine. You do not want to always click that if you don't trust that. Hopefully you trust me. Say the first few people who do this, who know me, put in the comments section you trust this. It worked. It didn't kill your computer. Anyway, I'm going to hit Control V now to paste that into that spot. There's a lot of stuff going on here, a lot of calculations. So I'm going to take it a second for it actually, well, you can see the bar, status bar, before it actually populates all our formulas and stuff here. So it's almost done. It's still working. Okay, so it's done. So this is that bit of G-code. And like I mentioned, it goes down. How many lines is it? We're getting close. That's more than halfway. So that took 804 lines. I'll not start at line 12. So 800 lines, basically, of G-code for that first pass. That's only one pass we're going to make on that bit, on that part we're cutting out. So I'm going to go through each line what these all mean here. 1 means that's the first pass. I'm going to hit Control, arrow down, get the very last line. Notice there's a space here, and the software sees, hey, that first bit's done, so it counts to number 2. Eventually, we're going to put this G-code again here. In fact, I'll do that right now. Multiply G-code. That's what this step does right here. So I'm going to multiply it. Again, it's going to take a while because it's adding a lot of G-code because there's 25 passes. It's going to copy that 25 times down here. And if it waits too long, I might actually pause this a second and start up again when it's done. So it says it's done. What I like about this is online. This is Google Sheets, if you didn't know that already. Google Sheets, it's all online. I didn't download anything on my computer. You won't have to download this. You'll copy it into your own Google Drive, which almost everyone has it. It's almost automatic. If you set up so many things, you get a Google account that you probably don't even realize that. But if you comment on a video ever, or if you watch videos and it has a list of videos that it forwards to you, that it knows who you are through that. That's through your Google account login. So what we did, when I clicked that button, it created the G-code again here. This is the exact same G-code here, just copied it again. Notice it says 2 here. That's the second pass. I'm going to hit Control arrow down, and a few more times. That's 3, the third pass. I'm just going to hold Control down and arrow down, and at 25, it should be the last one. Whoops, I went too far. Control arrow up. Okay. Notice how that's the 25th pass. It'll keep counting here because it sees that space. That's how that formula works. But we know we're done here. That'll be the final line of G-code when we actually are running this on our machine. I'm going to click above here and arrow down once. So I already explained what this column does. That's the counter, so we know which pass we're on. This one here, I've even hidden a few columns here, but I break out this bit of G-code into individual columns. So this column is for the G. If it's a G0, G1. G0, what that means, it's moving from point to point in a straight line. G0 means it's going at the rapid rate set on your machine. So whatever your speed is for doing things, usually it's not cutting, it's above and moving to the next toolpath or next spot. That's your max rate there. G1, again, is point to point. This time, you set in a speed. That F100 right there, that's 100 inches per minute. So G1 means move to a point, and this one, it's lowering the Z axis down at 100 inches per minute. We have a G1 here. Next line skips G1. If you have formulas or points like this, and there's no G in front of it, it assumes the last one used. So these are all G1 till it sees a G0 or something else again. I mentioned before, we don't want to work with the curves. You saw me change the point to point to point. That would be G2 or G3, work with curves. Working those formulas was too much for my brain to handle and too much for me to program this, so that's why I went point to point. It makes a lot more lines of G-code, but I don't care. The computer worries about that. It's not for me to worry about. The next line just looks if there is an X in this column here. So there's an X here. This one has Z and Z, so there's no X's there. And here's an X again. So all it looks for is an X. The X max is where we look at that. So X 1.2300, X 0.12300. This column is always the X value. Since we're talking that, here's the Y, same exact thing. If there's a Y present in that line, it puts a Y here, and it takes that number. Y 5.1204, 5.1204. Those do never change. Now the angle, this we're getting that trigonometry I talked about. So it knows that going that way, that's a 9-degree angle. Now we got a few variables here, and it's not exactly the same on that one, so it's working backwards to get that same thing. So it's going to say it's 8.97 degrees, so it's 30 thousandths of a degree difference. Multiple reasons for that. This one, it's an ugly formula in here. You can see all these things and whatnot, but you'll notice it's taking B5 divided by 2. Well, B5 is right here, which is the size of the end mill. Divided by 2 is the center point of that end mill. I mentioned that before, how the G-code follows a path. It's assuming the center of that point. So to get the angle to work out right, I had to take off the size of the end mill. And then later I'll put it back in when we do things later. So these formulas get crazy complex. Now, the X minimum, that would be on the very top layer, the 0 layer. When we looked at this, I'm going to add those back in. The top layer would be here, but of course 0 layer is 0 depth, so we're not going to do a pass of 0 depth. The first pass will be, well, in this one 0.05, but in the one I'm doing there is 0.04. So the first pass is not going to be that 0 depth because we're not cutting there. So, like I say, the minimum would be a 0 pass. The actual one we're doing right here, the new, is 1.0794. This is 1.0731. So what are we? I can calculate it out. What the heck? Let's find out. So the new is 10794, 1.0794 minus 10731, 1.0731 equals 0.0663. So 6.3 thousandths. And that's how much it moves out each step. So we'll go back to here. In this one, it was a different calculations, 0.0079. Our actual one is, oops, calculator. .0063. So for this example, this is the first pass. So let's remember that number right there. We just said 10794. This one's 0.0857. So if we took that number we originally had, go back up, go down, and if we added that to it, it should come out to that next number. And the next line will be that much again. And the next line, that much again. That's why we have that stair-step effect. The crazy thing about this, it's doing that not just once for the whole thing, it's doing for every single point. It's a different angle. As we get wider out in that shape we had, as we get further out here, so like here, that angle is going to get increased. As we get inside, it's going to be less. Another thing to show what I'm talking about here. So example, here's that same 9-degree angle, but the further we get away from 0, that angle is going to change. So out here it would be a much more drastic angle, and here it's a less drastic angle. So the angle gets less or more depending on how far we are from that edge. So like you say, at some point we're going to see up to, what's the biggest angle we're going to see? 10.96 is probably the maximum point. So I'm almost 11-degree angle at the maximum point, and we're getting down to 696. Is that the lowest one? So that's the difference in changing the angles. We're calculating all this every single time, all these distances and the minimum max. So many thousands and thousands of calculations going on. And it takes it 30 seconds or so. That's kind of the good thing. This being online is great. We don't have to pay for software. We're not doing things. The only problem is it's sending a lot of data back and forth. So that's why it can be a little bit slow calculating this stuff, up to a minute maybe for a complex one. So strengths and weaknesses. But by you being able to do this without installing any software, do anything, I think that's a good deal. So we've talked about the angle, the minimum, how we calculate that. The max, this one again, is the exact same thing as that number right there. That is the last pass we do. Well, let's go to the last pass. I've probably lost half the people watching now, or at least their heads are spinning by trying to explain something quite complex that I'm not good at explaining. So here, minus 1.23. That one is minus 1.23, which this is the G-code we're going to use finally, minus 1.23. I don't have the zeros on there, but exact same number. So that final pass of G-code, when we paste that in, will be that one we created basically in vcarve, though it'll be a different depth than we showed there. That final pass will be this final pass here. And notice we're almost 20,000 lines of code here. Again, that's a giant number for my brain to comprehend in all these calculations, but the computer doesn't really give a darn. It could be 100,000 for all it cares, though I think my formulas stop at 50. So if you do something more than 50,000 lines, you'll have to copy and paste these formulas down further, but no big deal. So we've talked about all these columns. The Z, let's mention that one a little bit. I'll go back to the top, cut down. So this first pass, it's 0.04. So if I go down to pass 2, it'll be 0.08. And oh yeah, there it is. Yeah, 0.08 when it actually pops down after going over it goes over the clamp and comes back down, 0.08. 0.2. 6, so it's always divisible by that number, 0.04, and it keeps getting deeper and deeper. That's that stair step we showed before. It keeps stair stepping down at an angle to get that final cut. So F only gets shown every once in a while. That first line was F100, and honestly, whatever you set your machine up, it's going to show that speed. I have it set for 100. It's always the exact same thing for mine, so it's kind of redundant, but it does show it each time. The computer doesn't care if you show it every single line or once, whatever. Once you set it, it keeps using that until you change it to something else. So the last thing to do on this spreadsheet is to assemble everything back into this G-code column. This will be the G-code that the machine actually runs, this column right here. And it's pretty simple, really. we all do is take columns that matter here, and it's in one field. So we always take G if there's something there, which there is. These first 4 lines, there's nothing there. You can actually see there's even a little space there where it would have been. Then we take X and the X new. Then we take Y and the Y number, which that one never changes. Then if there's Z, we take that, and the F if that exists. So this column, G1, X 1.1176, X 1.1176, Y 39056. This column here, G1, and that gets ignored if there's no X. It's just a calculation error. But G1, and then Z 0395, F100. We can pick any line we want. It'll do the same thing. X 1.1022, X 0.1022, Y 23561. Does that all the way for the whole 20,000 lines. So that's all of that. We've shown you how we delete this column with that, how we multiply it out. The next step is to highlight this column, and it's if you tried to highlight one and arrow down to hit those 20,000 lines, it would take you quite a while to go down 20,000 lines. So this button here, click this, it highlighted all, right click, and copy. So the next step, we take that bit of code and paste it into G-code again that we can take out to our machine. So I'm going to paste that into a file, and I took a G-code file like we showed before, and I took out all of the movement that we talked about, all the actual tool paths, deleted that. I put little headers here so I know where to paste my G-code into. I'm going to do a save as, and I'm first have to change that to do all, because we don't want to save this as a .text, we want .ngc. You see I've done this before. I'm going to call it CNC. That's kind of my little thing, so I know it's going out to the CNC machine. Just call it 123. Save. So now that file's called that instead of blank. I want to keep that one for future use. And I'll right-click, paste, and there we go. Notice how it says 19875. So that's how big that file was. It was very big. So we're good. So I'm going to file save. And we're going to close that. I will copy this file onto my thumb drive and go out to the CNC machine and run that and see what we get. I have this set for 100 inches per minute as the speed, but there's so many drastic changes in direction that it can't get up to that full speed except for the very ends. It's closer to 60. So once I do my actual staves I want to do that have a much more gentle curve, it'll go at 100 or even 150. I'm confident I can cut that. So this took 10 minutes. I'm sure I can get it down to 5 minutes, which is such an improvement. 20 staves times 5 is 100 minutes. So, a couple hours, I can have most of a drum built. I look back at like that puzzle drum I built. I had 40 hours invested in that before I even had a roughing of a shell glued up. This, even though it won't be as dramatic as the puzzles, it'll still be awesome, and I have some good ideas to make this a fun drum. I can be working on drums so much faster and not invest so much time in a single drum, so I'm quite excited. If you notice closely, you see it pops over those clamps. That was important to me. You didn't want to cut through the clamps. Otherwise, I'm doing each side by itself and twice as much time doing setup and getting things ready to go. So I am quite happy with how this worked out. And if you look close, you can see the angle on that. Here is a final shot of that stave. Zero cleanup. Obviously, we'll do a little sanding on that, though. Actually, since that butts up against another stave, it wouldn't take much to clean off the fuzzies and have it ready to go. I'm very happy with this process. I've done 3 totals, I said before. They come together great. Once I compensate for any warping that's in there, you clamp it up. Very tight fit. So I am happy. I'm sure in a future drum you'll see this technique used, and we'll go from there. In the bottom of the video description, there's a link to take you to the spreadsheet that we showed earlier. So if you click that link, it will take you here. And there's that Wavy Staves spreadsheet we talked about before. This is a shared folder. It's on my drive, a shared folder that anyone can get to. It should be locked down so you can't make changes, but if you can make changes, please don't. What you should do is right-click and make a copy. By doing that, it will take it to your own Google Drive, and you'll be there. It takes a second for it to move. So to get your Google Drive, almost everyone has a Google account already. All you do is go to Google, make sure you're logged in if you're not, click the 9 buttons there that says Drive, and it's already done. Here it is. So that's how fast it is. It takes about 30 seconds or so. Right here, go the message that it's been copied. And there you go. I can open it up here. Unlike the one that's on the shared drive, on this one, you should be able to make changes. So I'm going to hit 0.25. Sure enough, I can make changes now. We'll go 4. So it's yours to play with, your heart's content. If you mess it up somehow, delete it from yours and download it again. If you made it to the end of this video, I sincerely want to say thank you. I also want to say, what is wrong with you? You need to get a life. If you watch something this geekiness for 35 minutes, you probably have an issue. Sincerely though, thank you for watching this. Please consider subscribing to my channel and give me a like. We'll talk to you later. Have a great day.